Hi, this is Miss G. So we're going to talk about Unit 6 bonding. So what I'd like you to do is get your Unit 6 bonding notes, and you should have a periodic table at the same time. So chemical bonding. Bonding is about the force that holds groups of two or more atoms together and makes them a unit. So we have different types of bonds that are determined by electronegativity. So if you remember that electronegativity, when you go across a period, an energy level, that it increases as you go across, and then if you go down a family vertically, then it decreases. So I am nonpolar covalent if I'm between 0 and 0.4. That's determined by the two elements involved in the compound. If I'm covalent, I'm two nonmetals. So if you notice in A, you're pretty equal. Polar covalent means you have a little bit of difference. You're a difference between 0.5 and 1.9. So I'm still two nonmetals, but I'm a little bit different. Ionic, we have a big difference. We're 2.0 or greater. So this is talk about the two elements involved in the compound. So this is our electronegativity chart. You also have a chart in your worksheet packet. If you look on page 3 of your worksheet packet, you also have an electronegativity chart. So ionic compounds, basically we transfer electrons when we're doing ionic compounds. So for example, when we look at like sodium and chloride, sodium has 1 valence, chlorine has 7, right? So what happens is sodium transfers that electron to chlorine so that it can get its octet of 8. So ionic bonds are type 1 metals or transition metals. A cation and an anion have ionic bonds. So they have a large electronegativity difference. So the larger the difference, the more ionic the compound. So some examples: potassium bromide. That's a metal and non-metal. They're totally across each other on the periodic table, so that's ionic. Calcium chloride. If you look at calcium chloride, are totally on opposite sides. And then if you look at the electronegativity difference between calcium and chloride, it's pretty large. Calcium is 2.0. Chlorine is 3.0. So that's a pretty large difference. And which is more ionic, calcium sulfide or barium fluoride? So we're going to look at the one that's further apart. So barium fluoride has, this is barium there and fluorine there. And then we have calcium here and sulfide is here. So there's not as much difference. So we say that barium sulfide is more ionic. So ionic compounds form crystals. They stack together in groups. They have high melting and boiling points. They're hard and brittle. They can conduct electricity because the ions separate. They have strong bonds and solids, and they're solids at room temperature. So molecular is about 2 nonmetals. The covalent bonds are a sharing of electrons, and they actually share electrons. So a nonmetal and nonmetal, or a nonmetal and a metalloid have covalent bonds. So nonmetals and metalloids have similar electronegativities. So one atom doesn't have a larger attraction for electrons than the other. that results in transfer of electrons. There are two types of covalent, nonpolar covalent and polar covalent. So molecular compounds, nonpolar covalent, have 0 to 0.4 electronegativity difference. They share equally. So some examples are like N2 and O2. They have the same electronegativity, so there's no difference. Polar covalent have a low electronegativity difference. So some examples are carbon monoxide. If you look at carbon and oxygen, there's a slight difference. So they have a little bit of a difference in nitrogen and oxygen. Nitrogen monoxide also has a low difference. So that those two are polar covalent. So which is a covalent bond and which is a polar covalent? So actually, let's see, HP, so hydrogen is 2.1 and phosphorus is also 2.1, so there is no difference. So that one would be covalent. Polar covalent would be the carbon monoxide. So there's a slight difference there. So then that would be the one that is polar covalent. So covalent compounds are also called molecular compounds because they form molecules, just nonmetals, lower melting point and boiling points, soft, not very soluble in water. They don't conduct electricity because they are one compound. They don't separate into ions. They tend to be liquid and gases at room temperature. So let's look through these and decide which is ionic, nonpolar covalent, polar covalent. So calcium chloride is quite a difference in electronegativity. So we're going to say that that's ionic. So that's a sulfate ion. So we're going to say that one is polar covalent because there's a slight difference. Same with sulfur dioxide. Again, there's a slight difference. So we're going to say it's polar covalent. So O2 would be covalent because there's no difference. And let's look at nitrogen. So nitrogen looks like it's about 3.0 and hydrogen is 2.1, so it's 0.9. So we're going to say NH3, nitrogen trihydride, is polar covalent. And then the last one, sodium chloride, so we're just talking about the bonds now, is ionic because it's a large difference. All right, so we're going to stop right here. That's it. One thing you should talk about with your shoulder partner is how many valence does each group have. Okay, we're going to stop.